can't use the.
Wow.
So this one you're going to want to put copper metal. That's going to be your control. So you'll need to cut a piece of the copper from over here.
How big?
Copper metal. Just a small piece and then kind of turn it around. Make sure you have goggles on when you put it in.
Aluminum ones?
Okay.
You filming? Yes. So you're going to put it in there now. Oh, look at her. She's got it so good. Now, do you think this will react?
Probably not.
No.
Isn't the solution copper?
Yeah, this solution is copper. That's kind of how it's a control. So you'll know it's obviously copper solution if you have no reaction there whatsoever. The chloride is not going to leave the ion and go to the metal because the ion is already in abundance. So these other ones you get good reaction going on. What do you think you're making in there?
Rust.
What metal are you making? Starts with a C.
Copper?
Copper. So how much of the solution did you put in the well plates?
10 drops.
10 drops. Nice job. Are you ready, Brendan?
I think so.
Good. Have you done any time trials yet?
Oh,
For track?
running? No,
No.
not yet. Oh, we did one. It was a mile.
What'd you do?
Wait, what is...
I don't remember.
What do you want to do it in?
This is Johnny.
Under 6.
Okay. Specifically, you have a target time?
Under 5:55.
5:55 is good.
Oh, you're still...
I am.
So for the initial one,
Yeah.
it's just like the reaction,
Uh-huh.
and then the observations, is it like after?
Exactly.
Okay, but then what's the final and then remaining?
Well, the final will be when after you've let it go for how long are you supposed to let it go?
Oh, I didn't read that.
What?
Oh, it's 5 to 10 minutes. My bad.
There you go. So if you go to 10 minutes, it's like salt water will start to freeze at negative 10 degrees Celsius, but it'll continue until it gets to negative 21, I believe, is where its end point is.
Okay, how cold is space?
Very cold. 3 Kelvin. So it's very cold. If you don't have a heater, you're basically going to die or have some way of preventing the heat loss into the outer atmosphere. I think they use solar panels, and they pretty much try to stay in the light of the sun so they can get that solar energy. They're labeled. You should see a label on them. Whether it's aluminum, zinc.
Oh, this one's Z. This one's I.
Oh, that's steel. It's a substitute because we're running out of some of the washers. The washers are really nice. They're labeled. You can see here this one has an I on it for iron, a Z for zinc. They only give you a little bag, so we had to do some mossy zinc, some steel wool, aluminum foil substitutes. They don't reuse very well. Once these are used up, we really need to. Right. Let's see how we've got a good reaction there.
Yeah, we're finished.
All right. Now we'll probably do another lab on this, and a qualitative lab where you're going to measure amount of copper. Here we're just showing you that there are different things that react with the copper and the chloride. The chloride is the nonmetal that's causing this reaction. It's a single replacement reaction. Remember that, where we have one element here. So is copper a more active metal or a less active metal compared to, let's say, aluminum? Which one's a better provider, aluminum or copper?
Aluminum?
Aluminum is. Aluminum's higher on the activity series level.
Oh.
So it's basically going to provide its electrons with less ionization energy. Every metal requires some type of energy to lose its electrons, and the most active ones require less. So copper is going to require a little bit more from the chlorine than the aluminum will. So aluminum, a little bit less ionization energy required. So you probably made the most copper from the aluminum compared to the zinc. See how there's more copper there? Ask, what defines toxic? If you're in a business and you are releasing mercury into the sewer system, that's going to be a problem. Same with lead. What else would be considered toxic? Chromium, cadmium, arsenic. Arsenic would be high on the level of danger. So if they notice a high level of this coming into the sewer system, they're going to try to trace where it's coming from. Like if we were dumping lead down the sink and the sewer system started noticing high levels of it, they would trace it back to us and they'd come to us, and what would they do? They're going to fine us. We can be fined for dumping toxic chemicals down the drain. So that's one of the reasons why we were very careful about doing that. The ones we're using today aren't considered toxic. But anytime you get lead out, you have to be very careful with it. You can't dump it down the drain. You have to put it over here in the, where it says right here, metal waste container. Everybody see this? And then it's supposed to be taken and then disposed of properly. Well, you have to call them. So that's part of the reason why I don't like doing large volume labs with metals that are toxic, because it's hard to clean up. Not everybody follows directions. Sometimes they'll dump it down the drain, and then we have an MSD issue, and I don't really want to pay the fine. Right, that is correct. Nice job. Naomi on the bell work.
Can I get points for that?
You will.
Hold on, Miss Nair, I'm getting this.
You're going to round that to 4 past the decimal, but that's another story. Just take it to here. Grams.
Alright.
Iron. Yeah. So you would have rounded it to like 44,000 grams. Fe.
From industrial processes contain toxic or valuable metals that can be removed and then either reused or safely disposed. Reclaiming useful metals can reduce the cost and environmental impact associated with obtaining new supplies of these materials. Reclaiming toxic materials can reduce the cost and environmental impact of waste disposal. In this activity, you will investigate the usefulness of using several different chemical reactions to remove copper from a waste solution containing dissolved copper chloride.
Oh, well, let's just assume that you have a business, right? And you are putting something in your waste that is your wastewater that you're putting out from your company. What will happen to you if MSD determines that you are dumping something illegal?
You get fined.
Yeah, you're going to get fined. The most common things would be like heavy metals. Oftentimes, businesses that are industrial, like Ford Motor. Now, if you went back into the 70s, how did Ford Motor get away with not dumping it in the MSD system?
They took it outside their district.
They dumped it. No, they didn't do that. What they did, they went to like your waste dump. They put it in barrels and took it to a waste dump. Jacob, there's a waste dump out by Valhalla, a little bit past Valhalla, called Penn Run. And it was a national waste dump because nobody knew what was placed there. So it kind of fell under the federal government to clean it up. Ford wasn't the only company placing things there. General Electric was as well back in the 50s. They didn't really know chemically how to clean up some of these toxic chemicals, so they just put them in barrels and then took them to a dump. And there were places out in the country they'd be like, yeah, that's fine, just put it over there, give me $100, and that's kind of how it worked. Unfortunately, some of these chemicals were leaching into the streams, and that's not good. Right? It starts affecting life. So there are huge regulations on that right now. So in the lab today, when you get over there, there are rings, little washers that have letters on them. A Z stands for what?
Zinc.
Zinc. Now if you run out of zinc, there's a container that has zinc in it, and you can use some of that. Also, if you run out of aluminum, we have aluminum foil.
Can I get points for that?
A small piece. What's the control going to be? Raise your hand. What's the control? No. What metal's the control? No? Copper. Now the last thing, you should look to see which one of the metals produces the most copper. So they're going to react, the copper won't obviously, but the other metals will. Whichever one produces the most copper tells you what?
No reaction.
It's higher where on the activity series? Is it going to be higher on the activity series or lower on the activity series? Right. The most reactive one should be higher on the activity series. Like sodium is really high on the activity series. So remember we talked about what type of reactions are you working with today? Double replacement or decomposition? Raise your hand. No? 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 Single replacement. It was a trick question. Observation. Yes. All right, you ready?
So bro, that's zinc?
No, this is the aluminum and copper chloride solution.
That's copper chloride?
So where do you think that's going to be on the activity series?
Highly reactive.
Yeah.
Okay,
Nothing happened.
so then in 4 we observed for 5 to 10 minutes.
Yes.
It's been 2 minutes.
Okay.
Oh my
I like your hair color.
Thank you.
It's nice. You should take that shirt and then hair color and you'd
No.
like be perfect.
That would be weird.
That'd be amazing.
Colorful. I love
That would be traditional.
This class is 2022 shirt. Everyone could get these for like $15.
We are going to be able to use that at the science fair, right?
I will do everything I can. If you Nice job, Kunik, on getting the first answer. You got the units right. Excellent. Keep working hard there.
That can be removed and then either reused or safely disposed. Reclaiming useful materials can reduce the cost and environmental impact associated with obtaining new supplies of these materials. Reclaiming toxic materials can reduce the cost and environmental impact of waste disposal. In this activity, you will investigate the usefulness of using several different chemical reactions to remove copper from a waste solution containing dissolved copper chloride.
Now, if you own a business and you are dumping heavy metals into the sewer system, you're going to be fined by MSD. They will come out, they'll even shut down your business. Yes, heavy metals like lead, arsenic, mercury. Now, about 10 years ago, there was a teacher over at Sacred Heart that dumped some mercury into a drain.
Did they get wired?
Yeah, the hazmat team had to come out and extract the mercury from the sink it was placed in. Mercury is very dangerous if you get it in water. It's not good. Right. Now, Mr. Clements, they used to have a barometer. You can measure pressure with it. You know that? There was a barometer in his room, and it got taken out. And a student, knocked it over. And it was a big mess to clean up. They had to call the hazmat in to come clean up that as well. So we don't have mercury anymore in the building because of that. Now, on your sheet, right, you're going to see what type of reaction today? A combustion, double replacement, or decomposition? Raise your hand.
No reaction.
Hey, I got one.
No reaction.
No?
No reaction.
Decomposition?
No reaction.
One of them will be no reaction. Synthesis? None of y'all are right. He's right. One of them will be no reaction. No.
Single replacement.
Single replacement, yes. Now, I didn't give you the single replacement option. She thought of it on her own, which is very good. So you're going to do a single replacement. You're going to have an element, and then you're going to have the copper chloride you're going to mix with it. Now, one of them will react the most. That is, one of them will produce the most copper. So what does that mean?
Who's the best one?
Is it higher, middle, or lower on the activity series? Yeah, it's going to be higher, so it's going to be closer to like sodium as far as reactivity. Now, every metal requires some type of energy, they call it ionization energy, to react. It just doesn't do it on its own. It's going to require that. And some metals require less. Like sodium requires less activation, not activation, but ionization energy. Copper, gold requires a lot of activation energy to do a reaction. It's very stable, gold is. That's why people like it on jewelry, because this one is, yeah. Now it's not pure gold. Why do you not want to have pure gold in jewelry? It's just soft, yeah. Your diamond might fall out. They say at least 10 karat to 14 karat for diamonds.
Without the Z.
It'll say on there.
There is an aluminum. Do I use
Rebecca.
It doesn't say.
Sorry, I called you Rachel. It's just they're so close together. Rachel, Rebecca.
Steinecker.
Yeah.
The one that's not labeled aluminum. So one of them are labeled.
Most likely.
Okay.
That's the one that should react the most.
And the iron is the. Is the iron the steel one?
Yes, that's a substitute. Steel one's a substitute. I was.
I do have. You're the same.
I'll tell everybody that
Like hurt yourself. Over here, Alex is so proud of you. How's it looking here?
Plastic spoon.
Some good reactivity there.
I know, that's crazy. It started going steaming.
Steaming it. That's crazy. So write down what you see on the data table. Action today. Tell me, is it synthesis or decomposition? Raise your hand. No. No. I know. Which one is it though? It's a reaction, but we talked about. What? Which type? Single replacement. Very good, man. Looks really good. Have you done the copper one yet? That's the control. So you want to put 10 drops in there and see if it reacts.